For this poster presentation, we would like to share our work on tuberculosis biosensor. A few facts on tuberculosis. In 2019, the largest number of new TB cases occurred is in Southeast Asian region, followed by African region, and one of the biggest also is Western Pacific. And also in 2019, 87% of the TB cases occurred in these countries. Among them, the highest number is in India, Indonesia, and China, and the rest. In 2019, 1.4 million people died from TB, and 10 million people fell ill with tuberculosis worldwide. This TB is also present in all countries. TB is also present in all countries and age groups, but supposed to be TB is curable and preventable. Multi-drug resistant TB, MDR-TB, remains a public health crisis and a health security effect. This traditional method is still being used worldwide, which is sputum smear microscopy or AFB test, as well as this culture method. So culture method is actually a very selective and sensitive method, but it requires a long time, around 6 weeks, to be completed. Whereas sputum smear microscopy is a very fast method, but unfortunately, it can contribute to uh, misdiagnosed and some it is not very sensitive. So in our work, we are trying to detect this antigen CFP10 ESEC6 complex uh, secreted by the TB infectious TB infected patients in their sputum. And the bioreceptor that we use is antibody and aptamer that is selective towards the CFP10 ESET6. And we are developing the electrochemical based biosensor for this TB detection. So this is basically the structure, the cartoon structure, showing that the modification of the electrode and the immuno-based structure of the. This is the modification of electrode where we are using antibody-based, okay, for a set of antibody modified being immobilized on top of the electrode. And we have this GP graphene polyaniline modified electrode to enhance the current. And we are using a combination of ferrum 304 or ferroxide combined with gold nanoparticle as the enhancement or as a tag for the signal generation of the biosensor. The same, the same principle is also being used, but we replace with, instead of antibody, we replace with aptamer, which is selective toward the CFP10 ESET6. This is the process of producing Fe3O4 peroxide and combined with the gold nanoparticles. And these are the images from HR10. So this is process of conjugation of the antibody on top of the nanoparticle. The same protocol is being used for aptamer. The detection mechanism for this biosensor is based on the electro-oxidation of the gold nanoparticles. Okay, this is the peak where the electrooxidation occur. So the schematic diagram, uh, where the process of the whole process happens, starting from the modification of the electrode, the mobilization of the biomarker, the aptamer, and the exposure of this aptamer towards the antigen, the sample, and then followed by the tag antibody tag with the Fe3O4 gold nanoparticles. The interaction of the antigen and aptamer also uh, has been confirmed through SPR analysis as well as CD techniques. We have tested the developed biosensor with sputum sample with minimum treatment, and the protocols involve a bit of heating incubation, and this is the simplified protocol. And we managed to get a good results, very promising results from this sputum sample analysis. For this project, we would like to acknowledge University Putra Malaysia, University Science Malaysia, as well as Nano Malaysia Berhad as our funder, and also Ministry of Higher Education.